Hello everybody, welcome back to NLP1. As part of NLP1, we have started the unit on computational phonology. In computational phonology, we are going to look at different components. We have already talked about phonetics and phones, particularly the sounds of English, vowel sounds and consonant sounds. We have also looked at syllable structure. In this video, we are going to look at phonological rules and how to represent those phonological rules in terms of transducers. When you say phones are realized differently in different contexts. For example, if you consider a sound like t in the two words top and stop, the sound t is pronounced differently in the word top and it's differently pronounced in stop. In the word top, the t comes with a puff of air, which is t. So it is called aspirated t. Whereas in the word stop, t is not aspirated. So in a detailed transcription, we call aspirated t as this. We write it as t with a superscript h, and unaspirated we mention it as it is. But the difference is when you have a detailed transcription, we use square brackets, right? When we do not give a detailed transcription, then we put it in between slashes, and slashes represent the phonemes and these represent allophones, right? So allophones are variants of a phoneme. So while the phone t is called a phoneme, the variants t or r or t are called allophones. That is, aspirated t or a flap or a dental influenced t are called allophones. Transcription that uses phonemes is referred to as broad or phonemic transcription. With phonemes, we call it phonemic transcription. When you transcribe with allophones, that is in between square brackets, then we call it as narrow transcription or phonetic transcription. Okay, phonetic transcription gives us the allophones, the variations of sounds. Phonological rules. So the relationship between a phoneme and its allophones is often captured by writing a phonological rule. That is, if you consider a phoneme p, it is realized as a p when it occurs at the end of a word. For example, if you take a word like top, you can pronounce the word top with p released, that is, you open the lips after producing p, or you can even produce the sound without releasing air at all. Like you can say top, that is, you don't release. You can also say top, right? You release. So when you don't release, it is p with a mark like this, right? So this is an allophone. So phoneme p, when it occurs at the end of a word, so your hash mark tells us it's a word boundary. Hash mark tells us it's a word boundary. That is, at the end of a word, if a phoneme p occurs, it can be unreleased. This rule says the phoneme p changes to unreleased p, that is this, at the end of a word. Hash is used to represent a word boundary. Here is another rule for a flap. A flap is again an allophone of t, which occurs between a stressed vowel and unstressed vowel, right? This is a stressed vowel and this is unstressed vowel. Then you have r. For example, you have butter, right? The t here is a flap, right? But a here is stressed vowel and a here, schwa, is unstressed. When you have the phoneme t occurring between a stressed vowel and unstressed vowel, it becomes a flap, right? That means we need conditions to change a phoneme into an allophone. That is, the surrounding sounds influence the sound in between to become a variant of a phoneme. Now, how do we represent these phonological rules in transducers? As a first example, look at the following. We have t becomes r, which is a flap between a stressed vowel and unstressed vowel. Stressed vowel is given a mark over the V. V represents vowel. Look at the transducer. In this transducer, you will see the t becoming third. The flap is represented as dx in alphabet. We are not using IP here. It gives the symbol from alphabet. So t is the lexical level and the r is the surface level, right? Surface phoneme. So t changes to r here from 1 to 2. That is, when t occurs after a stressed vowel from 0 to 1, you can see, or you can even see here, right? Stressed vowel. Then after it changes to r, there has to be another unstressed vowel. If unstressed vowel doesn't occur, this will not change to flap. This becomes ungrammatical, right? It is illegal. So this rule, this transducer tells us that there should be a stressed vowel, either this or this. Then it is followed by t, and that t is followed by a unstressed vowel. Then that becomes your final state possibly. In traditional phonology, many phonological rules apply between lexical form and the surface form, right? There is a lexical form and there is a surface form, as in two-level morphology. And sometimes these rules interact with one another. That is, one rule feeds into another rule, or one rule blocks the other rule. When our rule, the output of one rule affects the input of another rule, that is, when it feeds into the other rule, it is called feeding. When a rule blocks the other rule to apply, then it is called bleeding. Okay, feeding and bleeding. So that is, output of one rule affects the input to another rule. One way to implement rule interaction in a transducer system is to run transducers in a cascade. Right? What we do is, we have several rules applying and one rule influencing the other. So what we do is, we put all the rules together to form a cascade. For example, consider the plural suffix in English. It is pronounced as is after the phones s, sh, ch, j, j, j. Right? These six sounds are called sibilants. So if the plural marker occurs after any of these sounds, then the plural morpheme is pronounced as is. The sound is pronounced as is. So the word beaches, beach, beaches. Beach is the singular, beaches is the plural. The plural here is pronounced as is. You can see that because it is preceded by ch sound, an affricate. Right? This affricate is a sibilant. So this is what we call plural suffix changing to is. Okay. There are other plural suffixes, right? S and z. So s occurs after a vowel, after a voiceless sound, like cat becomes cats. Z occurs after a voiced sound, dog, dogs. Right? Now, out of the three sounds which occur as plural form, s, z, is, we need to choose one of them as the underlying form. One of them as the underlying form. That will be in the surface. That will be in the lexical form. Remember we said lexical form and surface form. So that form, one of these forms will be the lexical form, and these three forms will be on the surface. So let's consider Z as the underlying form. That will be in the lexical form. So Z is the underlying form. Z has to change to S in certain contexts. Z remains as Z in certain contexts. Z changes to is in certain other contexts. Okay, that is, other forms like S, Z, is are derived from Z. So look at the rules here. These are phonological rules. Traditionally, Z, it changes to E, right? Z is changing to E when there is a symbol and there is a morpheme boundary, and Z occurs here, becomes E and followed by Z. Okay, so when you have a Z changes to E after a sibilant and a morphological boundary, then before Z. This is your E addition rule. So it becomes is, right? Then you have Z becoming S in the context of, the slash means in the context of a minus voice, that is voiceless sound. Voiceless sounds are p, t, k, s, right? Ch, sh. These are voiceless sounds, and there is a morpheme boundary. So and followed by a word boundary. So if there is a voiceless sound before the plural morpheme, that is, plural morpheme is realized as s. So for example, let's look at what happens in the case of sibilants. You have batch morpheme boundary and z is the plural morpheme, right? This is your lexical level, batch morpheme boundary and z, and this z now has to change to E, right? So it changes to E, that means Z is substituted by E and Z. Rule 1 applies, right? Then rule 2. Can rule 2 apply? Rule 2 will not apply here, because Z becomes a S when it is preceded by a non-voice, by a voiceless sound. So this rule will not apply, right? This rule will not apply now. Okay, so rule 2 will not apply when you have other sounds. Like now there is no morpheme boundary. After morpheme boundary you don't find Z, so it will not apply, right? What's happening now? The first rule is blocking the second rule. It's bleeding, right? In some cases the first rule makes the second rule apply. That is, the output of first rule will be used as the second input for the second rule. So when you have 2 or more rules like this, we need cascading, right? So each of these rules can be represented by a transducer. So each rule is a transducer, and since the rules are ordered, the transducers would also need to be ordered. So if you have 2 rules like this, each rule is a transducer. And how are you ordering? You say first rule first and the second rule second. You cannot have the other ordering. If you have this ordering first, let's say second rule applies, then what happens? Batch morpheme Z. Now when second rule applies, Z changes to S, and you got a wrong input. It becomes a wrong output. You'll get batches, right? Batches. And first rule will not apply because there is no Z at all to apply. Okay, so first rule has to apply first, and the second rule has to apply second. There is ordering. So when you make each rule as a transducer, those transducers should also be ordered. That's what we mean. So you make a cascade of all the transducers, and each one applies in a particular position in the order in which it is located. So if you have 2 rules, it's okay. But if you have many rules, then you have to have many levels. That means running a cascade, particularly one with many rules, can be unwieldy. If you have many levels or many transducers, then ordering them, running them will become a huge task, right? Instead, we would like to do it parallelly. Koskinemi, in his two-level phonology, right? Two-level phonology is an alternative solution to this. He observed that most phonological rules in a grammar are independent of one another. What we're saying is, we are saying one feeds to the other, one bleeds to the other, okay, but not necessary, not all rules, only some of them. So when only some of them occur like that, all the other rules can be independent of one another, right? And then what we do is, for feeding and bleeding relations, we follow the different conditions. We'll put some conditions on it. Okay, we'll see how to do that also. Instead of following the rules one after another, or transducers one after another, we can use them parallelly. So Koskinemi proposed that phonological rules be run in parallel rather than in series. The cases where there is a rule interaction like feeding or bleeding, we deal with by slightly modifying some rules. So Koskinemi's two-level rules is a way of expressing declarative constraints on the well-formedness of the lexical surface mapping. You have lexical level and surface level mapping. Between them, what we are doing is, we are going to have certain constraints to obtain a well-formed structure, a correct structure, grammatical structure. How do we do this? So two-level rules also differ from traditional phonological rules by explicitly coding when they are obligatory or optional. That is, traditional phonological rules, they apply one after another. But in two-level rules, what we do is, we'll say some of them are obligatory, some of them are optional. So we use 4 different operators. Like, for example, we use a double arrow, which it has to come here. Okay, the double arrow has to come there, here, and the double-headed arrow rule corresponds to traditional obligatory phonological rules, while the single-headed arrow like this implements optional rules, right? The most important intuition of the two-level rules and the mechanism that lets them avoiding feeding and bleeding is their ability to represent constraints on 2 levels. What it is, on both the levels, on the lexical level and surface level, we will have certain constraints so that we can avoid feeding and bleeding of the rules. How are the two-level rules represented? Here is a rule: A changes to B. Okay, in this context, that is, A is preceded by C and followed by D, then A changes to B. That means if the word is CAD, it becomes CBD, and this is always this, right? It's always realized as this. When you have A changes to B, similar condition, but it may be realized because we are using the arrow which is on the right headed. Here it is a left-headed arrow, it is a right-headed arrow. When it's a two-headed arrow, we say it must be realized as B in this context and nowhere else. Nowhere else it is realized, only here it will realize. And we can also use a slash and the arrow, and we say A is never realized as B in this context. Okay, always realized, may be realized, optional, must be realized in nowhere else, and never realized, negation here. So the symbol A star colon B means a lexical A that maps to a surface B. Thus A colon B or colon C means A is realized as B after a surface C. By contrast, A colon B and C colon means that A is realized as B after lexical C. The symbol C with no colon is equivalent to C colon. We have already seen this in previous classes. C colon C is nothing but C, right? We just mentioned C. That means a lexical C maps into a surface C. two-level rule constraint. Now look at this. On the lexical level, you have a sibilant morpheme boundary and z as the plural marker. When it is sibilant morpheme boundary and z, right, then that z realized as e and z. When it is voiceless and then morpheme boundary and z, then it is realized as s, right? So e is inserted when the last sound of the word is a sibilant, and z changes to s when the last sound of the word is minus voice or voiceless, right? And that's what your two-level rule says. Z changes to s, right? Must change, and nowhere else when you have voiceless sound. Or empty place is substituted with e, right? Again, must when you have a sibilant before the boundary, before the morpheme boundary. Let's now see how we can represent this in terms of transducers. So here is a transducer for I insertion or E insertion. What we see here is when the morpheme boundary and then you have z, the plural morpheme, and they are preceded by a sibilant. So you have a sibilant. If it comes across a sibilant, if the word comes across, if the word ends in a sibilant, and that can lead to the morpheme boundary which becomes empty, or you have a sibilant here and a morpheme boundary becoming empty, then that empty can be substituted with e, and that is followed by z at the lexical level and followed by boundary. So you have e is inserted when it is preceded by an empty, which is actually created by a rule that morpheme boundary changes to empty, and then followed by a lexical z, then e is inserted. This is your transducer for e insertion. When you have z devoicing happens when there is a voiceless sound and there is a morpheme boundary which changes to empty. Then it is followed by z, right? And that can change to s, which can be another transducer. But here basically what we are saying is the morpheme boundary changes to empty before after a voiceless sound and before lexical z morpheme. So how do these transducers run parallelly? So you have e insertion, you have z devoicing, both run parallelly depending on the word. So here is a word like foxes, you have s, which is a sibilant, right? And if the sibilant is followed by a morpheme boundary, then you have e insertion, right, which goes to 2, and that e insertion is done here. That is, you delete the morpheme boundary and you insert e, and z remains. Z also goes into that, and then you have a morpheme boundary that will create your z, or morpheme boundary goes empty. So you have is when it is foxes. But suppose you say here it is not fox, but here you have some other sound like t, then t is a voiceless sound. So what happens? Your e insertion rule will not apply. Then what applies is only your z devoicing. So z devoicing, what happens? The morpheme boundary should go empty, and then z has to change to s by the transducer, right? It's basically what happens is you have your morpheme boundary changes to 0 here, changes to 0. It will not change to I. Okay. So we have seen simple rules like devoicing or e-insertion, etc. But you also have some other issues which are a bit complex. So we will consider one such issue, one such advanced issue called vowel harmony. In a language called uh, Yokuts, and a dialect of it you have Yavilmani, and this dialect is spoken in Native America language in California. It has a very complex phonological system, and in this language a suffix vowel changes its form to agree in backness and roundedness. Vowels are described in terms of rounding and backing. So you have a back vowel like a, right? You have front vowel like e is front vowel. So you have learned this in phonetics. So backness and roundness. So when a suffix vowel changes its form to agree in backness and roundness with the preceding stem vowel. So you have a word with a vowel, right? And that stem vowel changes to whatever the suffix has. If the suffix has a back vowel, the vowel in the stem also changes to back. If the vowel is round in the suffix, the vowel in the stem also changes to round. For example, a front vowel e will appear as back vowel u if the stem vowel is u. Okay, so let's look at an example here. So in Yakuts, a suffix vowel changes its form to agree in backness and roundness with the preceding stem vowel. So how? You have dup is a stem, hin is a suffix, right? Dup, hin. Now, because in the stem you have a rounded vowel, u is round. Your lips are rounded when you say u. So e changes to u. Look at this, u, right? U is a back vowel, e is a front vowel. U is a rounded vowel, e is a unrounded vowel. But e changes to u. That means both in backness and roundedness, the vowel in the suffix changes to the vowel in the stem. So you have sil become and plus hin, both are back and front and unrounded, so they remain as it is. When you have a word like bok and suffix al, o is back, a is also back, but o is round, a is not round. You can pronounce and say a, not o. O is round, o, right? So because there is a vowel, rounded vowel, this a is also round, becomes round and becomes bokol, right? Similarly, khat, a is back and a is another back, so remains as back. So if you have two features, round and back, and everything becomes round and back, or if there's only one feature which is round, then it can have also influence. That is, either roundedness influences the vowel in the suffix, or backness influences the vowel in the suffix, or both can happen, right? That's what we see in these examples. This is one rule where you have vowel harmony from stem to the suffix, right? The vowel in the stem is influencing the vowel in the suffix. Look at this. There is a lowering rule. Second rule is lowering rule, which is also vowel harmony. Lexical, you have hot, right? You have a glottal stop, u, which is round, long, and back, right? Back, long, round. And you have the suffix it. E is front, unrounded, and short. It's also short, right? When these two combine, look at what happens to the suffix. Suffix has become u because of your first rule. First rule says if you have a rounded vowel, you influence the suffix vowel, make it round. So that has become e has become u. But e is front and short, right? E is front and short. And so what happens is, an e is high, e, U is also high, U. But when you say O, you're lowering your jaw. O, right? E, A, U, O, U, O. So U is higher, O is lower. So there is lowering which happens. U becomes O. Length remains the same. Lowering. So lowering is applying from suffix to the stem. This is the reverse. Backing, rounding applying from stem to suffix. Lowering applying from suffix to stem. So look at this. Meek, E is front, high, unrounded. Front, high, unrounded. E. And you have E here. Right? E. Now what happens is E becomes ma, right? Lowered. The vowel is lowered. E becomes E. You can see that. You can just pronounce both. E. Right? A is lowered. Right? So the vowel in the stem gets influenced by the suffix and gets lowered. That is called lowering rule. There's a third rule which is called shortening rule. So you have a long vowel becomes a short. Here is sap, A is long, A is long, and hin, E is short. So A becomes a, sapin. Saduk, U is long, hin becomes sadokun. Right? There is rounding applying on this thing, and U becomes O, U, O, lowering happens, and also length has become short. It is not sudokun, it has become sudokun. Right? Suduk becomes sudokun. Right? O. O is lower, short. Okay? That means there are three rules we see in vowel harmony. Vowel harmony is one influencing the other, one vowel influences the other. Either the suffix, vowel in the suffix influences the stem, or vowel in the stem influences the suffix. There are three rules which we see. One is backness and roundness influence, another is lowering, third one is shortening. So each rule can apply in a particular order. Each rule can apply in particular order. Right? Because if one rule applies the first and the second rule applies another later, then there may be changes. Okay, so let's look at certain words and see what happens. So you have all the three rules, and all the three rules can apply in an ordered fashion. Rounding applies first, lowering applies first, shortening applies next. So when you have hutuin, right, hut, so you have rounded long vowel, you have short front, unrounded. Okay, rounding applies first. Rounding is here, right? Rounding is here, that is stem influencing the suffix. So the stem has a rounded vowel, so the suffix in the vowel in the suffix is unrounded, so this should become U. Right? U becomes U. Okay, this becomes U first. Then lowering. Now, when lowering applies, both are high. Both are high. If one of them is lower, then it should apply, right? But not necessary. When is one and one is short and then is long, yes. So this vowel U becomes O. U, O. It becomes lowered. Then after lowering, you have O, right? So you have a long vowel and you have a short vowel. That long vowel gets influenced by the suffix. If the suffix has a short vowel, that long vowel should become short. So the O becomes O. So you can see ot, hun. So the rule should apply this fashion: rounding, lowering, and shortening. You cannot reverse the order. Okay, so each rule can become a transducer, and you need a cascading of transducers or cascading of rules. This is one architecture. But you can also have an architecture where the rules or the transducers apply parallelly, like your two-level rules, right? Where you have rounding applies, lowering applies, and shortening applies. Okay, they apply parallelly. How do you do that parallelly? That means you have to apply some constraints on the lexical level and surface level. And the lexical level, if you say when does this O becomes E or O, only then O is rewritten as O, right? Then O becomes O. When does O become O? That is long becoming short when it occurs after, when there is a short vowel after it. So we need to build in those transducer the context constraints on each of these levels, and then you can apply all the three transducers applying parallelly. See you in the next video.